Hello, everybody. Welcome to today's lecture. So, today we're going to continue on with the section on fractions. So, last time we talked about multiplying fractions and dividing fractions, and just also generally about what are fractions and how do you reduce them, what are equivalent fractions, all that. So, just as a reminder, so as a little review, okay, to multiply fractions, say something like this, we just multiply the top, multiply the bottoms, okay? So we do 3 times 2 on the top, 4 times 5 on the bottom, and we get 6 over 20, okay? Now, to reduce fractions, like this 6 over 20, for example, this can be reduced down a little further, because notice that 6 is equal to 2 times 3, 20 is equal to 2 times 10, so we can cancel the 2's out and just get 3 over 10. Okay, so we're looking for a common factor between the two, because when we do that division, we just get 1, and 1 times anything doesn't change what the thing is. Okay, so the other thing was dividing fractions. Okay, so let's see, 3/4 divided by 2/5. So this is where we want to do the same change flip. Okay, so we leave the first one the same. We change the division to multiplication, and we flip the second fraction. Okay, so we take the reciprocal of it. So we do 3 times 5 on the top to get 15, and 4 times 2 on the bottom to get 8. So we end up with 15/8. All right, and this is an improper fraction because the top is bigger, but that's how we're going to leave it. Okay, we're just going to leave things as fractions for now. All right, so make sure you're comfortable with this stuff because we are going to use, not the division, but we are going to use the multiplication and the reducing in this section when we talk about adding fractions. Okay. So for adding fractions, first we're going to talk about adding, subtracting fractions with the same denominators. Okay. Remember, denominators are the bottom numbers. Okay. When two fractions have the same denominator, we typically say that they have a common denominator. Okay. And if they don't, then we typically say we need to find a common denominator. Okay. So let's look at an example like 1/4 plus 3/4. Okay. So what should we do here? There's there's an easy answer here, but let's try to frame it in terms of let's try to frame it in terms of how we were doing variables. Okay. So notice, for example, so I'm going to overcomplicate it for a second, if you'll just indulge me, and then we'll go back to the easy way to do it. Okay. So let's say that this is well, let's rewrite this. 1/4 is the same as 1 times 1/4, right? 3/4 is the same as 3 times 1/4. So let's all agree on this first. Okay. 1 times 1/4, clearly that's just 1/4 because you multiply anything by 1, it stays the same. The 3 times 1/4, we're doing 3 times the top, and then remember we can think of that as 3 over 1 if we want to. So we're doing 1 times 4 on the bottom. So we can see 3/4 and 3 times 1/4 are the same thing. Let's frame this back in the way we were framing chapter framing it in chapter 2, what if we let 1/4 be x? So this is 1x plus 3x. Okay. What we learned in that section was that if we have the same variable, we can combine them, right? We can add them together. So we can combine like terms here, and we would have 1 plus 3 times x, or 4x, right? Now x is 1/4, so just swap that back in. And now we have 4 times 1/4, which is 4/4. And then you can simplify that if you want to 1. Okay. So like I said, we're overcomplicating it here just to prove a point. Just to show why this works, okay? So ultimately going from here, going from here to here with our final answer, what did we do? Well, we left the denominator the same, and then we just added the top numbers, right? And that's justified right here because we kind of ignore the denominator by calling it x, and then we just focus on adding the top numbers. So that's ultimately what we end up doing. So you don't have to do this whole thing every time. You just want to recognize that if two numbers have the same denominator, all we have to do is add their numerators. Okay. So 1/4 plus 3/4, these have the same denominator. So we just add the numerator and we keep the same denominator. Okay. So we get 4/4, which is 1. Now, let's we can even verify this visually. Okay. If we have 1/4 of the square and we have 3/4 of this square, you can see that if we combine these two, if we add them together, we're going to have 4/4, or the entire square. Okay. So this is the way we can see it visually. So let's look at another example. Okay, let's say we have 7/3 plus 13/3. Okay. Again, these have the same denominator. So all we have to do is add the top, keep the denominator the same, and then we're done. Okay. So there's really not a lot of work to do. We're just adding the numerators together. Let's look at a subtraction problem. Let's say we have 5, 6, and we want to minus 2, 6. Okay. So it's the same way. We just want to subtract the top numbers, keep the bottom numbers the same. So 5 minus 2 on top, leave the 6 on the bottom. So we get 3/6. Okay. Notice that 2/6 is the same as 1/3. If we simplify this problem, and 3/6 is the same as 1/2, if we simplify the problem, we get this. So this is a little preview to the next section of what we do when they have different denominators. Okay. You can see these two problems are equivalent. So the way we're going to handle it is by changing the denominator of the fractions using the equivalent fractions. Okay. But don't worry about this just yet. We'll get there in a few minutes. Let me see. Let me make sure I haven't missed anything here. Okay. This is pretty much all there is to it. So let's just do a few more examples. What if we have negative 5/3 plus 7/3? Okay. So this is going to be negative 5 plus 7 divided by 3. So now we got to remember our rules with negative numbers. Negative 5 plus 7, you could take out a number line if you want to. You're going to start at 7, or I'm sorry, you would start at negative 5 and then move to the right 7. So you're going to end up at 2. Okay. What about negative 5/3 minus 7/3? So now on a number line, you would start at negative 5 and then you'd go to the left 7. Okay, so we're going to end up at negative 12/3. Now, negative 12/3, we can actually do the division, negative 12 divided by 3, and get negative 4. Okay. So we're using that chapter 3 stuff here. What if we have 2 divided by x minus 14 divided by x? Okay. Specify x does not equal 0. Just because if x equals 0, this wouldn't make any sense because we can't divide by 0. But x could be any other number and it wouldn't matter. Okay, so just to demonstrate that it really doesn't matter what the denominator is as long as they're the same thing, this is going to be, we're going to have 2 minus 14 on the top. Okay. So start at 2, go left 14, and we'll be at negative 12 over x. Okay, so take a moment, pause the video if you need to, and make sure you have this part down before we move on to the next part. Okay. So take your time with this and just do some practice problems. And when you're ready, unpause the video and we'll meet back in 4.5. Okay. Okay. So let's get started on 4.5. So this one, we're going to talk about how do we add and subtract fractions with different denominators. Okay. So the idea of this section is that we want to turn them into problems where they do have the same denominator, because then we can just do what we did in the last section. Let's look at one example of that. Let's think about, okay, what if we had a whole number plus a fraction? Okay. Well, if we think about division, we can be kind of clever with this. Okay, so this is just an example to get us started, so don't worry if this doesn't make complete sense yet. Notice that 3 is the same thing as 9 divided by 3, right? We know 9 divided by 3 is 3. Okay, so if we rewrite it like that, then we get this problem. And these are the same problem, but now we have two things with the same denominator. So it works out in our favor because now we can just add the numerators together, just like we did in the last section. What if we had 1/4 plus 1/2? Okay. Well, visually, okay, we have 1/4 plus 1/2. We can see we should end up with 3/4 if we put them together. So how do we get there? Well, we have to think about equivalent fractions. Okay, 1/2 is the same thing as 2/4, same thing as 3/6, same thing as 4/8, etc. Right? So we can use that second one in place of the 1/2 here. Okay, so this is back what we did in 4.1. And then we can see on the top it's just 3. So overall it's 3/4. Okay. So I'm just using the fact that we did this already in 4.1, but how do we really change from that 1/2 to 2/4? Okay. So this is where finding the least common denominator comes into play. LCD, least common denominator. Okay. And this is the same thing as the least common multiple. Okay. Find the LCM of the denominators. Okay. So for 1/4 plus 1/2, here we can change it to 3/4, so it's a different problem. The LCM of 2 and 4 is 4, right? 4 is a multiple of 2, 4 is a multiple of itself. So this is the smallest number it could be. So we want to make both denominators 4. Okay. One of them already is 4, so that one we don't even need to touch. But the second one, 1/2. Okay. Actually, let's focus just on the 1/2 for a minute. Okay, so the 3/4 already has a denominator of 4, so we don't need to change it. The 1/2, though, we do need to change. It doesn't have a denominator of 1/2. So what do we do to make it 4? Well, let's think about multiplication. Okay. If we were to multiply the bottom number by 2, then we would have 2 times 2, which is 4. Is there any way we can do this, though? Well, we can't just multiply the denominator by 2 by itself, because now this would be a whole different problem. But notice if we multiply the top by 2 also, then what are we multiplying by overall? Okay. 2 divided by 2 is 1. If we multiply something by 1, it doesn't change what the number is, right? So if we can multiply 1/2 by 1 if we want to, we would still have 1/2. Instead of 1, we're writing it as 2 divided by 2, but that's still 1. But by doing it this way, we get this answer, 2/4. So we get an equivalent fraction with the denominator that we want, right? Now that they both have the denominator that we want, we can just add them together like we did in the first section. So we get this. Okay. All right, let's look at another one. Let's say we have 1/2 plus 1/3. Okay. So first we want to find the least common multiple of 2 and 3. Okay. Now, you can do this a couple different ways. You can list the multiples. Think back to 2.5. You can list their prime factorizations. They already are their own prime factorizations, so their least common multiple is just the product of them. So the least common multiple is 6. Okay. So we need to make the denominator of the first one, or we need to make the denominator of both of them 6. So now we have to change both of them. So we have to think, okay, what should we multiply 1/2 by so that it has a denominator of 6? Well, right now it has a denominator of 2. So what do we need to multiply 2 by to get 6? And the answer would be 3. Right. Whatever we multiply the bottom by, we should multiply the top by the same thing so that overall we're really only multiplying by 1, and then we're not changing the quantity of the number. Okay. On this side, with the 1/3, what do we need to multiply 3 by to get 6? And the answer is 2. And then we should multiply the top by the same thing. Okay. So 3 times 1 on the left here is 3. 3 times 2 is 6. 1 times 2 is 2. 3 times 2 is 6. Okay. Now we can just add them together and we'll get 5/6. All right. What if we did 7/10 minus 5? Okay. Oops, I'm sorry if that made a noise. So we need them both to have a denominator of 10. 5 doesn't even have a denominator, so we can think of the denominator as 1. So sorry, let me back up. We need to make it have a denominator of 10 because 10 would be the least common multiple of 10 and 1. Okay. So the 7/10 we don't even need to change. We just need to change the 5/1. So what do we need to multiply this by to make it have a denominator of 10? Well, the right number, the bottom number, sorry, is 1. So we need to multiply that by 10. That's the only way we're going to make it overall 10. So that means we have to multiply the top by 10 as well. Okay. So 5 times 10 is 50. At the bottom we have 10. So we're doing 7 minus 50 over 10, which you'll get negative 43. Okay. So we're just multiplying by 1 in clever ways at the end of the day. Okay. So there's only so many examples I can do. This is really important to practice on your own, though. So definitely make sure you do some examples here. Let me do one more. So we'll have a short video so that you can just do some examples on your own today. Let me think. How about 5/2 minus 7/8. Okay. So let's say 7/9. So we need the least common multiple of 2 and 9. Okay. Now I should mention, you don't even really need a least common multiple. That part's a little unnecessary. You really just need a common multiple, and any of them would do. You just might have to reduce at the end. Okay. So if you can think of another multiple off the top of your head that is common to both of these numbers, then great, that's fine. Like if you wanted to use 90, for example, because it was the first one that popped into your head, that would be fine. It just makes the numbers nicer if we use the least common multiple. That's the only reason we are. So the least common multiple here would be 18. 2 times 9. So for the 5/2, to make the denominator 18, we need to multiply by 9/9. Because we have to multiply the 2 by 9 in order to get 18. For the 7/9, we need to multiply by 2/2, because that's how we make the bottom 18. So on the top of the left one, we have 45. On the bottom, we have 18. On the top of the right one, we have 14. And on the bottom, we have 18. So now we can do the subtraction, and overall, we'll get 31/18. Okay. So 5 halves minus 7 ninths is 31 eighteenths. Okay. All right, so we'll end it there today. So make sure you practice some of this on your own because this is a very important concept to master. On the next video, we'll talk about 4.7, and then after that, we'll get into decimals. So thank you guys for watching today, and have a good one, and I'll see you for the next one.